Hey everyone, welcome to Tutoring. So today we'll be doing a short and quick topic video on integration via linear substitution. So last time we did integration via simple substitution, but this time, sometimes that technique doesn't always work. We have to use different techniques. So this will be considered, I guess, technique number 2 for integration, and it's called linear substitution. So what does that mean? Let's have a look at an example. Antidiff of x times by the square root of 2x plus 3, and then of course we antiderive in terms of x. How would you do that? Well, if we use this simple substitution, right? Because that's one function multiplied by another function, two functions, so that definitely allows us to do simple substitution. And to do that, we let u equals the function that looks complicated usually. So in this case, 2x plus 3. So you let u equals 2x plus 3, and then following the procedure, du dx equals to 2 when you derive it, and then dx equals to du on 2. But what is the immediate problem that you see? That x and that 2 is not going to cancel out, right? If you were to write it down, so I'm just going to write it on the side over here, x, and then it's square root of u, I'll just put it u to the power of half, and then dx is now du over 2. Well, you still got two variables. That 2 doesn't cancel out with the x. It's still x multiplied by u to the power of half, and then you antiderive in terms of u. But the problem is x is still there, so you can't really antiderive that, right? So you can't use simple substitution. But then there has to be a way to do this, right? Yes, there is, and we just have to go one extra step further. And if you want to get rid of that x, there isn't just one way of doing it, and not just by eliminating x. There isn't just one way. There is another way, and I guess the famous quote for that is, if you can't beat them, or in this case eliminate them, if you can't eliminate them, you make them join you. Okay, so I guess that's a way to easily memorize what linear substitution is, or to differentiate it from simple substitution. So you're gonna make x become u instead. Okay, how would you do that? Well, take a look at this function right here. U is equals to 2x plus 3. I can make x a subject. 2x equals to u minus 3, and therefore x equals to u minus 3 divided by 2. And then what this allows you to do is now you can write x in terms of u. So we have u minus 3 divided by 2. So I'm just rewriting this integrand right here. Multiplied by u to the power of half du over 2. So I'm just rewriting the same thing, but instead of writing x, I'm going to write x in terms of u. Okay, so once you do that, guys, you can bring the 2 and the 2 out, so that gives us the 1 on 4, and then that's u minus 3 multiplied by u to the power of half du, and then we just need to expand our bracket. U to the power of 1 multiplied by u to the power of half, we add the power, so that's u to the power of 3 on 2 minus 3 times u to the power of half, and then we're going to antiderive in terms of u. And then there we go, guys. This is a polynomial. We've done it before. We've seen it. And all you have to do is add power by 1. So 3 over 2 plus 1 is 5 on 2. And then we divide it instead. So 2 over 5. And then over here, it's u to the power of 3 on 2. We divide it. So it's 2 on 3 multiplied by 3. And that leaves us with only a 2. And then you put a plus c. Your last step is our last step is to multiply out our brackets, and I'll simplify it as well. 1 on 4 times 2 on 5, that is 1 on 10 u. So u, as we know, is up here 2x plus 3. So I'm just going to rewrite that, 2x plus 3 to the power of 5 on 2 minus 2 times 1 on 4, that's half. Of course, same thing with the u, 2x plus 3 to the power of 3 on 2, and then plus c. And there we go. This is your original function, guys. If you antiderive what we have here, the x multiplied by square root of 2x plus 3, this is what you should get. And of course, if you derive this, you should get back to the original answer. Okay, so this is technique number 2, integration by linear substitution. Hopefully this helps you understand more about the topic. And aside from that, guys, thank you for watching. It's a short one today, and I'll see you in the next video.